Hey guys, Professor, and we're back for another video, and inside this video we're going to be talking about chemical reactions. Chemical reactions are simply just elements combining with each other to either make compounds, or compounds breaking into their actual substances. Or we could also have different types of chemical reactions which involve bonding. So with that known, we're going to start off with talking about synthesis reactions. Well, synthesis reactions are simply just reactions you're going to see in most basic chemistry and daily life. So a synthesis reaction could involve something as simple as aluminum and oxygen. So if we have something like aluminum and then we have oxygen, remember oxygen is a diatomic, so we write that as a 2. So then we're going to have it produce as an ionic compound, so we have Al2O3. And let's just balance this. So we have 2 over here, and then we have 3 over here, and then we have 4 over here. So now that we have it balanced, all we're going to do is talking about how a synthesis reaction actually happens. So let's do that in a different color. So basically what's going to happen is that we have element A, which is aluminum, so let's write that as element A. Then we have element B, which is going to be an oxygen in this case. An element B and element A, which is aluminum and oxygen, are pretty much just going to combine and make an ionic compound or a different compound of sorts. And basically what's going to happen is that we're going to have element A and element B create some type of compound with each other. It doesn't matter if it's an ionic or molecular, it's just going to create some type of compound. And we just have to write B here. So that would be the general synthesis reaction, where simply we just have element 1 combining with element 2, and it's producing element 3, which is the compound. So that's a general reaction for synthesis. So if we move over to decomposition, all we're going to have is the inverse of synthesis. So we have synthesis, which is A plus B produces, let's just write that B a bit bigger. So we have element A plus B produces element AB. In decomposition, what we're going to have is, we're going to go this way rather than going this way. So what's basically going to happen is that we're going to have element 3 at the beginning, and then we're going to break apart into a simpler substances, which are element 1, so we have A, and then we have element 2, which are B. Pretty much what we're doing in this reaction, let's take an example. So let's take aluminum again, and let's grab aluminum chloride. So we have another ionic compound, and we have Al3, because remember it's an ionic, so the changing of ions. So, and then we have to break it apart into its actual elements. So we have Al, and then remember chloride is a diatomic, so we also have to write chlorine as a 2. So we have Cl2. And let's just balance this very quickly. So then we have 3, 2, and then our final one will just be 2. And pretty much what we're going to be doing in this reaction, as I talked previously, is that we're going to have pretty much the inverse of synthesis. So we're having element AB here, and then we're going to break apart into its simpler substances, and pretty much this is a decomposition of the actual compound. So pretty much what we're going to have is that this arrow is pretty much representing production is going to happen. So over here we're going to have some type of catalyst, for example, and this catalyst is going to create aluminum and chlorine into its separate elements. So now that we have that, let's cover on single displacement. So with single displacement, it's pretty much just one element pushing another element out of its home in a compound. So if you can think of an example with single displacement, let's take the example of a bully, for example. So if we have a bully and it's pretty much just going to take on a weaker element, for example, and it's pretty much just going to take that element out of the equation and just put it somewhere else on the equation, and we're just going to take its place in the compound. So if we have something like a single displacement equation, let's take zinc, because zinc is generally quite high on the electromagnetic scale, and it's showing that it's more reactive than most elements. So we have zinc, and let's do hydrochloric acid, because we know hydrogen is quite weak as reactivity comes. So we have HCl, and pretty much what's going to happen is that we're going to produce zinc chloride. Let's just write that as a Z rather than a 2. So we have zinc chloride. And then pretty much after zinc chloride is bounded, we're going to have hydrogen be left as a diatomic, which normally is. So we have hydrogen as a diatomic, and let's just balance this very quickly. So we have ZnCl, and then after we balance it, what it should look like is that we have 2 here, and that's now balanced. So now what's basically going to happen in this element is that we have element A over here, and element A is going to be the reactive element inside this reaction. So then we have element B, which is hydrogen, and then we have element C, which is going to be chlorine. And pretty much what's going to be happening is that element A is going to take element B's place, and now will become AC. And then this hydrogen is going to be left out, and it's going to become element B. And element B is now not going to be a compound with C, but rather simply going to be the lone element. It's going to be the loner of the single displacement reaction now. And pretty much that's all it is. It's simply just one reactive element taking another less reactive element's place inside a compound, and that less reactive element is pretty much just getting pushed out. So if you take this arrow example, pretty much zinc's coming in, taking hydrogen place, and hydrogen's just getting kicked out into the final reaction. So if we take another example, so let's take another single displacement reaction, because for this one, generally, it's one of the hardest reactions to understand at first. So let's take ammonium. So we have NH4, and we have bromine, for example. And then once we have bromine, let's do chlorine. And remember, chlorine is an atomic. So then, now what's basically going to happen is that bromine is going to get kicked out of this reaction. So now what's going to happen is we're going to have ammonium chloride. So we have NH4Cl. And then what's going to happen next is that bromine is going to be left on. Remember, bromine is a diatomic as well. And let's just balance this very quickly. So we have 2 and 2, and that's balanced now. So pretty much what's happening in this one again is that, let's just do it in a different color so we can outline. We have element A, and we have element B, and then we have element C. And again, element A is binding with element C, and even though it's not in the same order as last time, it's the same concept, because ammonium is still going to bind with chlorine, and bromine, because it's less reactive than chlorine, is simply just going to get pushed out. And this is what's happening in the final reaction, as we have ammonium chloride, and then we have bromine. So, once we cover single displacement, let's move on to double displacement. Double displacement reactions are one of the easiest reactions to understand. I would say it's quite similar to synthesis reactions, but rather than getting pushed out, it's simply just creating a bond rather than actually having an actual push out. So pretty much in this one, 2 elements are just going to have having bonding partners, and it's going to switch places. So what's happening in this one is, so let's take the example of ammonium again, because ammonium is a very good example to use with double and single displacement reactions. We have ammonium. Let's take chlorine again, because chlorine is also a very good element to use. And let's take sodium hydroxide. And with sodium hydroxide, it's going to pretty much produce that Na is going to bind with Cl. So we have sodium chloride, and then pretty much when sodium chloride forms, it's going to be left with ammonium hydroxide. So we have NH4OH. And this is going to be the general sample reaction for a double space. Let's move this over so we see the entire reaction. So with this entire reaction, we see that let's just do it in a different color again. So we have element A, we have element B, we have element C, and we have element D. And pretty much what's going to happen is that we have let's just get rid of this one really quickly. And pretty much what's going to happen is that we have element C and element D. And this is pretty much a compound. And what's going to happen is pretty much we're going to have AC form, or not AC. Yeah. So we have AD form. I mean, plus Bc. And we can see this in the example because ammonium is getting paired up with hydroxide and Cl because it's going to be more common for Cl to react with sodium to create sodium chloride. So sodium is going to react with chlorine and ammonium is going to react with the hydroxide. And that's going to create the compound of sodium chloride with ammonium hydroxide. So the general formula for double displacement reactions is simply element AB plus compound CD produces compound AD plus a compound BC. And this is going to be the general formula for double displacement reactions. Where pretty much just two atoms are creating a bonding. So in this bonding, for example, we have D and A and D creating a bonding, and we have a C and B creating a bonding. I've hoped I've explained double displacements, single displacements, synthesis, decomposition, and synthesis reaction, so now everyone who watches the video is now able to understand. If you guys have any questions, leave them in the comments below, and I'll be sure to answer all of them. Professor, and we're out.